Hello students, today I will be briefing you about relativistic mechanics as per your AKTU syllabus, Engineering Physics BTech first year. First, let's have a look at the syllabus. Relativistic mechanics. It consists of frame of reference. This definition is asked in section A 2-mark question. What is frame of reference? It consists of a set of coordinates which are used to define the position at a particular instant of time. Then two types of frames, inertial and non-inertial. A very favorite question, 2-mark of section A, give two differences between inertial and non-inertial frames of reference. Or another 2-mark question, section A, is Earth an inertial frame of reference? Yes or no? Galilean transformation equations which failed to work out and give correct explanation for many phenomena and were overtaken by Lorentz transformation equations. Lorentz transformation equations have been asked many times in AKTU in your section C part. Michelson Morley experiment, the negative results of this experiment, and what was the aim of conducting this experiment. Postulates of special theory of relativity, postulates like theorem, and they are two often asked in section A. One, all laws of physics hold same in all frames of reference. Second, velocity of light is a universal constant. Length contraction and time dilation go for the numerical part. Often you are asked, define length contraction, derive an expression for the same, and a simple numerical that a rod is kept in one frame of reference. It is moving with this much speed. What is the length in the other frame? Same thing holds for time dilation. Velocity addition theorem. Here we will be requiring two bodies and law of conservation and energy to derive an expression. Variation of mass with velocity. Till date, you must have heard that mass is a universal constant. Now you will be getting to know that rest mass, which is m equal to m naught upon under root 1 minus v square by c square, where m naught rest mass is a constant. Einstein's mass energy relationship, E is equal to mc square. Relation between energy and momentum, E is equal to Pc. And massless particle definition, a very favorite question for section A. So section A, what is frame of reference? Give two differences between inertial and non-inertial frames of reference. What are the postulates of special theory of relativity? What were the negative results of experiment? What are massless particles? So we begin with our syllabus now. Newtonian mechanics works very well where the speed of light is slow and the experiment that we are discussing can be observed by naked eye. For example, I say a bus is going on a road and a truck is coming from the opposite direction. At time 5 seconds, find the time when the two meet. Some like this. So this question you can see with naked eye, and in fact you can even do this experiment. So till here, where the object under observation has a velocity which is very much less than the velocity of light, Newtonian mechanics will hold true. When velocity of the object under observation approaches the velocity of light, not equal, but approaches it, like into 10 to the power of 7. Velocity of light is 3 into 10 to the power of 8. There we apply relativistic mechanics. Albert Einstein gave this special theory of relativity, which I am sure all of you must be knowing because he is known as father of science for this very relativistic mechanics theory. What is frame of reference? Section A. Motion of a body is described with respect to some well-defined coordinate system. You must have heard X, Y, Z, T, and this coordinate system will be known as frame of reference. There are two types of frames of reference: inertial or unaccelerated frame, non-inertial or accelerated frame. In inertial, You recollect this comes from Newton's law. All bodies, inertial law. This word is coming from there. So in inertial frame, Newton's laws are obeyed and laws of Newtonian mechanics hold true, while in non-inertial frame, Newton's laws are not valid. Now look at this question. This was asked in your section A of 2 marks. I have given bit extra so that you can remember for your exam. Inertial frame of reference, a frame of reference which is at a constant velocity with respect to the other frame, and acceleration of this frame is 0. Inertial frame will obey the Newton's laws of motion. Velocity, a train moving with uniform velocity. The non-inertial frame of reference, constant acceleration. Acceleration of the frame is non-zero. Non-inertial frames do not obey Newton's laws of motion. For example, a freely falling lift. So this is a favorite question of section A. Another very favorite question of section A is Earth an inertial or non-inertial frame? Justify your answer. Earth basically is an inertial frame. We know that Earth undergoes 2 types of motion: rotation, reason for day and night, and revolution around the sun, causing the 4 seasons of an year. So we cannot say that Earth is constant. It is moving. So this is an inertial frame of reference as it is revolving around the sun at a constant velocity. But Earth is also rotating at the same time due to centripetal acceleration. That in accordance with sun, it will be non-inertial. So this is a bit controversial answer. Obtain Galilean transformation equations show that length and acceleration are invariant under Galilean transformation equations. In order to give any answer of relativistic mechanics, you will first have to draw these 2 frames of reference. One, the inertial, and the other non-inertial. You will show the y-axis, the x-axis, and the z-axis. And you will assume that one frame we can say is at rest with respect to the other S frame and S dash moving with velocity v. For any point under observation, the coordinates of the point with respect to frame S will be x, y, z. With respect to frame S dash will be x dash, y dash, and z dash. If we apply simple mechanics to it, then we can say if it is moving in the same direction, then x dash coordinate, you can take it as x is equal, x dash coordinate comes out as x minus vt, and if it is in the opposite, you take it as x dash plus vt. This is simple mechanics. Now on this simple mechanics, Galilean tried to give his equations which could be used for explaining relativistic mechanics. He said that x dash is simply x minus vt or plus vt as per the direction of motion, y dash is y, z dash is z, and t dash is t. If I differentiate x with respect to t, I get velocity. So dx dash equal to dx upon dt is equal to, if with respect to t, so dvt by dt becomes equal to v. Similarly, your dx by dt can be written as ux, and dx dash by dt dash can be written as ux dash. If a photon is observed to move with velocity c, which is velocity of light, in frame s dash, then ux dash is equal to c. So c is equal to ux dash minus v. So ux is equal to c plus v. That means this is becoming more than the speed of light, which is not correct. That means this result is contradictory and not supporting the experiment result. So Galilean equations failed to some extent right in the beginning only, that they failed to explain the postulate of special theory of relativity, which states that no object travels faster than the velocity of light. But here they are saying it will be c plus v in one case, Secondly, they contradicted the result of experiment. What is Michelson Morley experiment? I will just explain you here. Michelson Morley experiment. Michelson Morley performed an experiment to determine the absolute velocity of light with respect to stationary ether frame. Ether, they assumed a hypothetical medium ether to be present throughout the universe so that they could perform their experiment easily and come out with certain mathematical equations to explain the Michelson Morley experiment. So what is experiment? Experiment is basically that all bodies, including Earth, move freely through the hypothetical medium called ether. It was contradicted that if ether hypothesis is correct, then it should be possible to determine the absolute velocity of the Earth with respect to stationary ether frame. Keeping this view in mind, Michelson Morley experiment was performed using Michelson Morley interferometer. The experimental setup of the apparatus, first I will explain you. Here is the experimental setup of Michelson Morley experiment. What exactly is happening here in this experiment is that a monochromatic source of light has been taken. Two plane mirrors M1 and M2 are kept like this, and a telescope for observing the fringe pattern. Two glass plates, one semi-silvered and one plane, inclined at an angle of 45 degrees are taken. Actually, we will be observing a fringe pattern here, and we will take out fringe width. When this experiment will be performed in different seasons of the year and at different places, we will try to find out whether there is any difference coming in fringe width. So this is the target of my experiment. I am here to take out fringes and fringe width. So fringe width comes when there is path difference between the rays that are reaching my telescope, when there is a monochromatic source of light and coherent sources are there. This you will study in interference, but here I am explaining you in short. Let us track this ray of light. It comes out from the monochromatic source of light S, falls on this semi-silvered glass plate kept at an angle of 45 degrees from the horizontal. Part of the ray gets reflected here, part of it is transmitted here, then it suffers an additional path difference because of the second glass plate that has been inserted to give an additional path difference, and it falls on the mirror M2. Since this is a plane mirror, this ray of light will be reflected back, as you can see here in the arrow, and again it is going to retrace its path here, and some ray of light will be following this path, reaching mirror M1. Again, this is a plane mirror, so it will retrace its path back. Now, what has happened? We have got rays of light originating from the same source, giving rise to coherent sources and having path difference before reaching my telescope. So condition for interference pattern is getting fulfilled, and I will now start observing fringes here. What I will do is I will find out the fringe width with the help of my very simple formula. Distance is equal to speed into time, and velocity is distance upon time. And then what I will do with that fringe width value, I will try to perform this experiment at different places and different seasons of the year to see what happens to my fringe width. Let us proceed. Monochromatic source S is taken and light is made to fall on it from the lens combination. The half silvered plate here A will be splitting this light into two components, one parallel and one perpendicular. The reflected component travels to the mirror M1 and is reflected back, while the transmitted component is reflected back from M2. Here, M1 M2, it goes and it retraces its path. Now, what happens? We will further draw the ray diagram because we have to derive an expression for fringe width. Our target is deriving an expression for fringe width. So what do? I just take the triangle part of the experiment so that I can apply some formula. Let me first explain this diagram to you. What is happening in this diagram? See, right now I told you Earth is not constant. Earth has rotation and revolution both. So by the time my ray of light comes from here, falls on this glass plate, gets splits into components, this mirror M1, in that specific time when the ray of light is going till here and coming back, will proceed to a new position M1 dash. And in that specific time period, the plane mirror M2 will also proceed to a new position M2 dash. This is what I have diagrammatically shown here. See, M1 was here. By the time my experiment took place, interference fringes got formed, ray of light retraced its path, came back, path difference took place. M1 took new position M1 dash, and mirror M2 took the new position M2 dash. And let us take this distance as D, this much distance as R. See, AM1 has been an AM2 have been taken as capital D, and velocity of light, we can assume the direction according to our convenience. If we are taking in the direction of motion of Earth, we can take it as C minus V, where C is velocity of light and V is the velocity of the Earth here. This direction V through which it is traveling, because we are assuming velocity of Earth. Velocity in the opposite direction will be C plus V. And for the mirrors M2 and M2 dash position, time will be distance upon speed, and the distance is capital D. So capital D upon C minus V plus capital D upon C plus V. Ray of light has gone and ray of light has come back. Once again, look at this diagram here. See, ray of light goes and ray of light comes back. So total time taken by the ray of light in going and coming back, D upon C minus V, D upon C plus V. We get 2D square, DC upon C square minus V square. Distance traveled is equal to speed into time. Speed, light travels with velocity of light only. So total distance traveled becomes, we put this value of T, which we have obtained here, 2DC upon C square minus V square in this expression, and we get taking approximation, 2D into 1 plus V square by C square, where what we did binomial expansion of this and neglected the higher order terms. Now this was for my horizontal part. Now let us solve it for the vertical part. Taking right angled triangle AM1 dash and R. AM1 dash and R. This right angled triangle has been taken and Pythagoras theorem has been applied to it. Values have been put and we get the value of T as D upon C into 1 plus half V square by C square. The binomial expansion, 1 plus x to the power of n is equal to 1 plus nx plus n into n minus 1 upon factorial 2x square plus and so on. So we have neglected all the higher order terms. Total time in going and coming back becomes twice of D. Total distance traveled is x2 is equal to 2D into 1 plus half V square by C square. Path difference will be the difference of these two distances, x2 minus x1 equal to 2D into 1 plus half V square by C square minus 2D into 1 plus V square by C square. So my path difference comes out as dV square by C square. If this path difference is corresponding to n number of fringes, then del x is equal to n lambda. So I equate equation 5 and 6 and I get the value n number of fringes is equal to dv square c square by lambda. If you have a closer look at this expression, Lambda will be the wavelength of my monochromatic source of light. V will be the velocity of the earth. C the speed of light. And for this experiment, DMM had approximately, Michelson Morley, approximately he had made it 10 meter. So when I just, and obviously wavelength of monochromatic source of light is around 500 nanometer. So we keep this value, we get the value of N as approximately 0.2. Path difference will be twice, and both path experience with this fringe shift, so it becomes 0.4. Now, when this experiment was performed at different seasons of the year and in different locations, no motion was found. Just think like this, that you are made to do an experiment on 10 samples and you come back saying that the reading of all the 10 samples is same. Immediately it becomes a big controversy. How can the experimental result for 10 places and 10 different locations be same? So this experiment was said that it is not working out to explain relativistic mechanics. Ether hypothesis became undetectable, and regardless of any motion of source and observer, there was the fringe pattern shape showed no change. So Michelson was asked to give an explanation for this negative result. He said that moving earth is dragging ether along with it, and hence there is no relative motion between earth and ether. Lorentz pointed out that actually there is a small error that is taking place in this experiment. The error is that they are not considering that when an object under observation is traveling with approximately the velocity of light, then the length gets shortened by a factor L into under root 1 minus v square by c square, that is length contraction. If this correction is taken considered, then this experiment might be successful. So consistency of speed of light also became contradictory here. Negative results meant that it was impossible to measure the absolute velocity of Earth with respect to ether plane. What were the two postulates of relativity? They are asked in section A. First states that laws of physics are same in all inertial frames of reference, and speed of light has the same velocity for all observers, independent of the motion of the source or observer. Next lecture, Lorentz transformation equations will be derived. Thank you.